in the economics department size. So the broad research agenda that I've been working on for a few years is to look at different government interventions and how they affect the private sector, how they affect firms, because sort of firms are as important as households or individuals in developing countries as being engines of growth. This is joint work with an ex-PhD student of mine who is now a postdoc at Duke University. What I'm going to talk about today is rural infrastructure improvement programs causally affect local economic activity. So the operative word here is going to be causal. I'm going to make a causal claim that because of these rural infrastructure improvement policies, is there a change in local economic activity? So I really don't have to motivate this too much, but physical infrastructure investments have been important drivers of economic growth. They've been important. They are important ever since the solo model of economic growth, that you invest in capital and it leads to growth. There is World Bank has a lot of previous World Development Reports which have sort of pointed to the importance of physical infrastructure investments. There's also a very large previous literature looking at the effects infrastructure provision, most of which is provided by the government, and have found positive effects. For example, there are papers on the effects of dams, of electrification, of rural roads and highways, of providing internet. Kay has some work also in Ghana, looking at the effects of infrastructure provision. Most of the previous literature, or the oldish literature, found positive effects. There is a more recent strand of literature looking at rural infrastructure investments, sort of rural road provision, rural electrification, and strangely, they haven't found any broad-based effects on households. For example, you provide rural roads to these extremely rural population, extremely remote populations in India, and there is no effect on consumption, on income, on education. Similarly, for rural electrification, there was a big scheme in India where some of these really less populated villages got these electricity grids. And basically, this electrification it did not have these transformational effects on the local population that policymakers have been expecting. So this has sort of raised this debate about whether electrification in itself is something that cash-strapped developing country governments should be spending on, or is there a higher bang for the buck somewhere else? Like, let's spend money on health or education, because infrastructure provision has not really had these transformational effects that people were hoping for. So one claim about this recent literature is that all of this recent work has mostly looked at rural households. They look at this rural infrastructure provision, and then they look at what happens to households. And one claim that I want to make today is that rural households may not be the right place to look for effects if you want to see what is the effect of infrastructure provision. There are multiple reasons to this, because rural households have a very low willingness to pay for electricity or for roads. Some of this is because of social norms. They feel that this is a right that they should have, that they believe that infrastructure is something that should be provided by the government, so their willingness to pay is very low. There are also concerns about the quality of provision of electricity, roads in many poor countries, based off of which rural households often express that they have very low willingness to pay for these sort of services. Okay. Another reason why rural roads, for example, have not had these transformational effects, my colleague here at the economics department, Sam Asher, has a paper saying that rural roads have not led to higher income or higher assets or higher consumption by these households. And one could conclude that that could be because they are too remote or in too remote places to be able to use any of these services. So broadly, there is where there should have been consensus. The infrastructure provision should be unambiguously good. There is this recent debate whether electrification and roads have any effects. So the claim I'm going to make that rural households may not be the right place to look for these effects. So what we do in our paper is to look at rural firms, sort of firms or people who use electricity and roads for their production and supply chain processes may be the right place to look if you want to really find out the effects of electrification and roads and infrastructure provision in general. Having said that, one major concern in all of this literature is broadly that to measure the effects of infrastructure on households or firms are extremely hard. And that is because infrastructure services or infrastructure provision is often place-based. By that I mean they are often directed either to, highways are often directed to places that are growing really fast, or, sometimes the governments have this altruistic motive and would provide infrastructure to places that are extremely backward. So by definition, these places are very different than places you want to compare them to. Okay, so people living in these areas are different, firms in these areas are different. So this poses this problem that how do you measure the effects of infrastructure? How do you find, for people who are treated or for people who get these infrastructure services, how do you find a suitable comparison group? Okay, who do you compare them to? Are you comparing apples to oranges, or can you find a suitable comparison group to actually look at the effects? Of course, the gold standard in this is to do randomized control trials, and Johannes has done some randomized control trials on providing sort of electricity grids to households. But these are often hard when you look at big government programs, right? So it's hard to convince the government that you should roll this out in a randomized way, where you randomly provide electricity and roads to some villages and not to others. So this sort of problems with evaluating large-scale programs with randomized controlled trials often leads to researchers employing quasi-experimental techniques. For example, doing regression discontinuity designs, difference in differences, and instrumental variables. The bigger problem also with infrastructure provision, especially in rural areas, is that it's very hard to find a setting where demand for these services will be high. Okay, so this is what I spoke about, that households often do not have a high willingness to pay because they think that this is a right, or they do not have, you provide them electricity, but they don't have a TV or other stuff. They don't have complementary appliances to use that electricity, or you provide them roads, but they are so far away from the marketplace or from the central town that it's actually of no use to them. So in this paper, we are going to solve a few of these problems. We are going to look at the effects of these rural infrastructure investments on rural firms. So firms, I don't have to convince many people that firms demand infrastructure services. They need electricity for production. They need roads for their supply chain. And we are going to use a regression discontinuity design, which sort of, it's not an RCT, but it gets very close to mimicking a randomized control trial in a quasi-experimental way. So I'll talk more about how I compare places that get these infrastructure services to places that do not. Okay. So the third thing, in terms of background, one thing that is often ignored in a lot of these impact evaluation papers are micro enterprises. This is an important and very, very important part of the population or of the economy or of the local economy, especially in developing countries. So what are micro enterprises? These are generally very small, often self-employed or employing family members or very few people. They are often not registered with tax agencies, so they are informal. And it's very often it's very hard to distinguish between households living in a household and producing stuff to sell. So very often these are enterprises that are based inside of households. Okay? The other reason this is very important is because of their prevalence and importance in developing countries. They are very important throughout the developing world, but in my setting, in India, 76% of non-agricultural employment is in micro enterprises. So this is a very, very important sector of any developing economy, but especially India. And so, of course, any analysis of when you want to look at local economic activity, you have to look at micro enterprises. Unfortunately, a lot of the previous work has ignored this sector, mostly due to lack of data. It's very hard to have data on these very, very small firms. So we are also going to, in this paper, also going to address that concern by looking at the entire firm size distribution, which includes large firms and very, very small firms. All right. So just to tell you the findings, and I'll talk more about the policy in a second, we find that this rural infrastructure improvement program, because of this, the employment places or villages that got this program or this infrastructure grants, the overall village employment increases, but this is driven by employment in micro enterprises. However, nothing changes for formal firms. So there is no change in sort of larger firms. All of the changes are coming from micro enterprises. This is at the village level. When I go and look at the firm, I also find evidence that corroborates it. So I find that micro firms are growing in size. When I say size, it means employment. Again, no change in formal firms. So seems like this infrastructure grant scheme, which is directed to certain backward areas, is generating employment, but that employment is coming from very, very small firms. That's the takeaway. On the extensive margin, I also find that there are new micro enterprises that are coming in, or the number of micro enterprises are going up in these places. Given that I said a lot about the fact that households and micro enterprises are often indistinguishable, you also find that wages and number of days for individuals in these places is going up. So something that a lot of the previous work has not found, we find some broad-based effects on people living in these places. Their wages and hours work, you can think of this as hours work, increases, and the household consumption expenditure or the monthly consumption expenditure also goes up in these places. Okay, so having spoken about the main results, we try to tease out why this is happening or what could be driving these results. So we find that overall the infrastructure investment in these districts is going up as measured by night light intensity. Night lights are measured by these NASA satellites at night, and we find that we find increases in those. We find that firms are claiming that there is a reduction in the probability of having a power cut. So it seems like electrification is improving, or electricity provision is improving. They also seem to suggest or self-report that there is a reduction in having no access to raw materials. So we are interpreting this as an improvement in the supply chain, sort of the connectivity channel. So both roads and electricity are improving. We find that these results, that employment increases in micro enterprises, are stronger in industries that are electricity and road intensive. Okay? So this sort of pushes the idea that it must be working through electricity and roads. And then these effects of having more number of micro enterprises and more employment is higher or larger in villages that already had electricity and roads before the policy came. So these are not happening in places that had nothing. These effects are happening in places which already had some baseline level of infrastructure, which sort of ties into some of the earlier results where you try to provide electricity or roads to places that had no roads and people found no effects. This is consistent with that story, that this you find the government is providing infrastructure in places that already had some baseline level of infrastructure, and those are the places where you see these effects. And then finally, I will talk a little bit about what I think where the money was spent, which is you find that places that are very close to the district headquarters, the district is supposed to spend the money, you find larger effects. But I will hand wave a little when I reach that point. Okay. So let me talk about the program. The program was called Rashtriya Sama Vikas Yojana, or RSVY. I will keep calling it RSVY. It was launched in the fiscal year of 2003-2004, when the central government identified the most backward districts in the country based on a completely transparent selection procedure. It was based on a score, and I'll go over how they came up with the score. This helps us do this regression discontinuity design, where we can compare districts that were very close in terms of their scores, so they were very similar in terms of their observables, but some got the grant and some did not. So that's going to help us with this concern of not comparing apples to oranges. So I'm going to claim that by comparing districts that are very close in terms of this score, which I will talk about, we are actually comparing apples to apples. Okay. So importantly, these eligible districts received these bundled grants. They received this sum of money that they could spend on improving rural connectivity, electrification, agricultural systems, etc. But the way it was done, that the district head or the head of the district, after consultation with sort of multiple parties, village heads, etc., would come up with a district perspective plan where they would identify infrastructure gaps in the district. What are these infrastructure gaps? For example, you have a road which, there's a road that connects to the marketplace, but there's another village and you need to connect that village to the marketplace using a bridge, or you need to build a bridge. The money could be spent on building that bridge, for example. So grants were supposed to be used to make complementary investments. So this is going to be important here, that this is not completely new infrastructure. It's not going to places that have nothing and building an electricity grid or building a road. These are places that already have something, and you are going to find the district is supposed to find these infrastructure gaps and make complementary investments. So in some sense, you can think of this as an infrastructure enhancing policy, rather than a completely new roads policy or completely new highways. So that's going to be important. So in terms of roads, it could be used for widening or strengthening of roads after the rains. It could be to build small bridges, or it could be to build a road to connect some village to a marketplace. Or for electrification, it could be to improve or get some new transformers, or to just strengthen the electricity transmission and distribution infrastructure. Okay. So the way this was done was that overall 147 backward districts were selected, but 32 of them did not have this score. They were hit with left-wing violence, so they were automatically selected. The rest were based off of these scores, or every district was given one of these scores. Okay, and every district was entitled to receive 450 million Indian rupees, divided equally over 3 years: 2004, 5, 5, 6, and 6, 7. So 3 equal installments of 150 million rupees each. Okay, so how did the government decide which districts should get this money? So the way this was done was, in the first step, the central government, so the government of India, wanted to determine the number of districts each state would get to receive this money. So India is divided first into states. So there are 30 odd states, maybe 30 to 35 now, and every state has districts within them. Okay, so district is a smaller administrative unit than the state, and within districts you have villages. Okay? So in the first step, the central government decided Okay, we want to give money to, let's say, 100 districts. These 100 districts will be divided across these states based on the percentage of poor people living in that particular state. So let's take any state, for example, Uttar Pradesh. Let's say Uttar Pradesh had 20% of all poor people living there. Out of a total of 100 districts, they would receive 20 districts. But that means they would receive grants for 20 districts. Okay, so that's how the first step happens. So we are going to take the first step as is, in the sense that we will not tinker with the first step because this is what the central government decided. After having decided the number of districts that each state would get money for, the money was sent to the state, and the state would have to then give the money to the districts based off of the backwardness ranking. So let's say a state like Uttar Pradesh had 85 districts within the state. Every state will have a ranking. Let's say you are allowed to give money to 20 districts. The 20 most backward districts in Uttar Pradesh would get the money based off of a score. So that's how it was supposed to be done. First, this is India, so things don't go exactly as they should. So of course, states did not perfectly do this. So we are going to deal with both those concerns. So and sort of these, so within state rankings of districts based off of this backwardness scores is what will allow us to do this regression discontinuity design. So what we are essentially going to do is compare within a state two districts that are very close in terms of this backwardness score, one which gets the grant and one which does not. So that's going to be the idea. Okay? So for everything else, it seems like they look similar. One got the grant, one did not. What happened to the place that got the grant? Okay? So that's going to be the idea. So how was this backwardness score determined? So note that the policy came in 2003, 2004, but these scores are based off of historical measures. Okay, so the first one was, so there are three measures, and then the score would be a weighted average of these three. The first one was the value of output per agricultural worker in the early 90s. The second was the agricultural wage rate in those districts, again from the mid 90s. And the third was the district's percentage of low caste, sort of economically and socially backward populations based off of the 1991 census. Okay? So since this was based off of historical data, it was hard for districts to tinker with this score. It was not that districts that wanted the money could change these scores, because these scores were based off of historical data. So then we're going to take a weighted average of these three and then rank districts based on this score. Okay, so does that make sense? So we first take a weighted average of these three historical measures. That gives us a cumulative score. Based off of this cumulative score, you can rank districts. And for each state, you can rank these districts. For each state, you know the number of districts that are eligible to get this grant. So let's say there is a state which has money to provide to 5 districts. You rank the districts in ascending order of backwardness scores. The 5th district is the cutoff district. Okay? That's the last district in that state that would get the money. Okay? So based off of these scores, we can get a cutoff score for each state. Why can we get that? Because we know the number of districts that that state has money for. And then we also have the list of districts that should have been eligible if this was perfectly implemented. Okay? So I'm a state, I'm allowed to give money to 5 districts. Those 5 districts should have been the districts that were the lowest on this backwardness ranking score. And so those are the list of districts that should have got the money. Sometimes the government does something else. Sometimes state governments don't do what the central government asks them to do. But we are going to econometrically deal with that. Okay, so this also then gives us these scores and the cutoff district gives us the running variable for the regression discontinuity. I'll show you. I'll show you what that means. So let's assume that there is again a state which is eligible to get money for, entitled to get money for 5 districts. The 5th lowest district has a score of 35. Every district that has a score lower than that, based off of this weighted average, should be treated. And we are going to look at the distance in, so the difference in the scores from that cutoff district as the running variable. Okay. So when we reconstruct the list of districts that should have been eligible and we match it to the districts that actually got the grants, we are able to generate an 81% prediction accuracy. So we are able to, we are able to predict up to 81% the districts that should have got the money. Of course, the 19% of the districts that should have got the money did not get the money. So we are going to econometrically deal with it. And I'll show you what we do. Okay. So just to give you a sense, this is panel A, shows you all the districts that actually got the money. In the green is our prediction using the reconstructed score that we generate. So you can see there is a reasonable match between the two. That's what we say we have an 81% accuracy. Of course, as you can see, a lot of it is sort of biased or sort of focused towards this eastern belt of India, which is generally poorer. And just to show you some other maps, this is how things looked in 2003. Okay, nothing is going on in this eastern belt. In 2013, it seems like things have lit up. Again, I'm not claiming that all of this is because of this policy, but I'm saying that things are happening in the eastern belt. So if I move quickly, you can see the difference. Okay. So again, eastern belt sort of concentrated in the eastern belt. That's where the backward districts are, and we can predict with 81% accuracy where the money should have gone. Okay. All right. So one more time, if you haven't heard me rambling the same thing again and again and again, what we're going to do is we are going to use this districts, every district as backwardness score, and the distance of that score from the cutoff district. And we are going to use that as a running variable. Every district with a negative score, the cutoff district gets a score of 0. Every district with a negative score should have been treated. Okay? Because it's the deviation of that district score from the cutoff district score. And these estimates, we will call them the intent to treat, okay? Because the intention was there to treat them, okay? So we are going to call them the intent to treat estimates, okay? Because we cannot match 100%, there are these states which are giving money to districts that should not have got the money. We will then, what we will do is also use our prediction, the districts that we predicted using the score, as an instrument for the actual districts that got the money. Okay? And these will be called treatment on the treated. Okay? So we will distinguish between intent to treat and treatment on the treated. For most of the presentation today, I will show you intent to treat estimates. Okay? So this is basically the districts that should have got the money. What is the effect on that? And I've already told you that the districts that the difference between the actual districts that got the money and the districts that should have got the money is 81%. Okay, so with 81% accuracy, we are telling you that this money was spent in the places that they should have been spent. Okay? So for most of the talk today, I will talk about intent to treat. Very importantly, this regression discontinuity goes very close to mimicking an RCT, a randomized controlled trial, if two of these assumptions hold for sure. The first one is that districts themselves should not have been able to manipulate the scores. Okay? If districts can manipulate the score and get a low enough score that they get the money, then it's no longer as good as random. Okay? So this first criteria is almost trivially met because, as I told you earlier, um, the three criteria off of which these scores were calculated were from the mid to early 1990s, and the policy came in 2003. So the data was already available, and the data was used by the central government to calculate these scores. So it was very hard for districts to manipulate these scores because they were already available in the public domain. Okay, so that's the first concern. And the second thing is that we want to look at estimates within a very narrow bandwidth around the threshold. So we have a cutoff district, and we are going to compare districts to the left, which is those that have a negative score, to those that have a positive score, but in a very narrow bandwidth, so that everything else or every observable looks similar across the left and the right. So that's going to be the idea. Okay, so if a few of these things hold, then a regression discontinuity design is as good as random, or as good, almost as good as the gold standard of a randomized controlled trial. Okay, so just to show you what I mean, why there was some slippage. So these are the scores. So distance from, so 0 is the cutoff district, the district in that state that was the last district to get the money. Everyone to the left, every district that has a negative score should have received the money. So the probability of receiving the money should have been 1. We should have expected a flat line here. Okay. Everyone to the right has a high enough score, so they should not get the money. We should have expected, with a probability of 0, a flat, sort of a horizontal flat line on 0. However, that doesn't happen. You see that some districts that should not have received the money get the money. Some of the districts that should have received the money do not get the money. So this is going to be a problem. We will instrument for this. But for today's talk, I will use every district to the left as treated, or those that get the money, every district to the right as those that do not get the money. Okay? And then what I'm going to do is I'm going to look at a very narrow bandwidth, and I'm going to compare districts which are in this very, very, very narrow bandwidth. So that's going to be the idea. And then you can ask me why the bandwidth, is it sensitive to the bandwidth? And I will change the bandwidth and show you that the results hold, even if I change these bandwidth specifications. Okay? All right. So the first question, again, I have already tried to convince you that districts were not manipulating their scores to get the money. So this is sort of a graphical representation of that. If districts were indeed manipulating their scores, you would have expected more districts to the left of 0, a bunching here, because districts would want to manipulate their scores and get a negative score so that they can get money. There should have been more districts to the left of the 0 line, but we do not see that. Okay, it seems actually the opposite. There are more districts to the right of the cutoff as compared to the left of the cutoff. So it seems like districts were not manipulating. In fact, if you see, the mass of districts to the right and left are similar, or at least statistically indistinguishable. Okay, so that's going to be the idea. We're going to say, at least from statistical tests and from this idea that these scores were based off of scores in the mid-90s, it seems like districts could not manipulate. Okay, are there any questions so far? Or no? Okay, I'm going to assume that I'm very clear. Yeah, okay, so just in sort of math terminology, what we are doing is, this is the intent to treat. We are going to have outcomes at the individual or village or household or firm level, and we are going to regress it on this RSVYDS. This is our prediction of the districts that should have got the money. Okay, so we are interested in this alpha 1. After controlling for a flexible functional form of the scores, and other observables that do not change over time. Okay. Importantly, we are going to have state fixed effects. What that means is that everything that I tell you, all the estimates that I'm telling you, is comparing districts within the same state. Okay, just across the cutoff. So what this is doing is going to compare districts to the left and to the right of the cutoff district within the same state. So it's going to compare within Uttar Pradesh two districts, one that got the money, one that did not get the money, but were very close in terms of the score. Okay. And I'm going to control for a bunch of observables just for the regression. Again, this is the same, but now the treatment on the treated. What I'm going to do is I'm going to instrument the districts that got the money, that actually received the money, using the districts that I predicted should have received the money. Okay, so it's slightly different. In this, I only use the districts that should have received the money. Here, I'm going to instrument the actual districts that received the money with my prediction. The intent to treat is what was the government's intention, their original intention of which districts they want to treat. Here we are taking into account the fact that state governments, there is always this messing around by the state government. They don't actually follow the rules. So we are going to do this instrumental variable regression as well. Okay. So this is important because this took me a lot of time. This is not an interesting slide, but just to say it took me more than 2.5 years to compile all of these data sets. This is the entire firm size distribution of India. So we use multiple data sets. The first one is the economic census, which covers all non-farm activity in India, which has small firms, large firms, medium firms, everything. We use 2 rounds of this. The 4th round, 1 round before the policy, just to show you that things would look similar, and 1 round after the policy. So one quick thing, the 5th round is going to be 2 years after the first paycheck went to the district. Okay, so it's going to be a short-term to a medium-run result. Then we are going to supplement this with national sample survey, but the unorganized manufacturing enterprise rounds, which covers, these are surveys that actually go and ask questions only to micro enterprises in India. Okay. So on this, I would say India is special, that the National Sample Survey Organization used to collect. I hope they would still do it, I don't know that, but until very recently, they used to collect data on micro enterprises. This is very, very different than working on many other countries. So I use 2 rounds of that. Then for formal firms, I use a panel data set of large firms, which is called the Annual Survey of Industries firm level data. I use it from 2001 to 2006, just to show you what happens over time. To look at households, I look at the household schedule of the NSS. Again, 2 rounds, 1 before the policy, 1 after the policy. Then we also use the population census of India, and also the nighttime light intensity, which is available from NASA. Okay, so these are NASA satellite images processed by the NOAA. Okay, so I'm going to say that all our results are consistent across these data sets, and for us, this is one of the major contributions of this paper. Okay, so just to give you some summary statistics, villages in these districts, each village has about 95 people who are working in some sort of a firm. 11 of them seem to be working in some formal or big firm. Most of them, again, 85% of 95 people seem to be working in small firms. When I say small firms, these are really small firms. On average, they have 2.5 employees. Okay, the average firm size is 2.5. So these are really small, sort of. You can think of them as mom and pop shops, but they also do manufacturing. Okay, Similarly, but the large firms are pretty large. They, on average, employ 53 people. So when you're thinking about large firms, these are 50 to 100 employee firms. When I talk about micro enterprises, you have to think about sort of you, your brother, and the brother's wife. Okay. So most of our effects. So when you see these effects, when I tell you the effect sizes, you should compare it with sort of the mean level of that firm. Okay. So any increase, I tell you 9% increase, the 9% increase will be off of a base of 2.5 workers. So one has to keep that in mind. The other thing I want to say is that these are relatively poor places. The sort of the weekly wage is around 450 rupees. The consumption expenditure in a month, sorry, this should be month, not week, is around 2,500 rupees, which is, I suddenly forgot, $40. Yeah, something, yeah, around $30 to $40. So these are poor households, really poor districts. Firms are really small. The other thing I want to point out is that these places are so backward that on average, a village in these districts has 0.22 large firms. So 5 villages have one large firm. So that's the idea here. Okay. So that also must be kept in mind when I discuss the results on formal firms. Okay. So the other thing is that you could say, okay, these districts look. You said they look similar in terms of their scores, but do they look similar in terms of other observables? So I show you that around the cutoff, which is very close to the cutoff, they look similar in terms of SC/ST population, agricultural wage rate, agricultural output, village population looks similar, electricity coverage looks similar, paved road coverage looks similar. So in terms of any of these infrastructure variables, at the baseline, they looked really similar. Okay, so there was no difference if you just look very close to the cutoff. That's the point I want to make. So given that's the case, some districts on the left are going to now get the money, districts on the right will not get the money, and that's the comparison I will make. Okay. All right, more stuff, even in terms of area, elevation. So they are balanced. Basically, these two groups that I'm going to compare are balanced. So I'm going to compare apples to apples. Okay. So I have about 20 minutes. Let me rush through the results. First question is about overall village employment. Does overall village employment increase in districts that got this money? And if it is indeed increasing, is it coming from large firms or small firms? That's the first question we ask. And we are going to use these economic censuses, which is the entire firm size distribution. We're going to aggregate it up to the village level and then show you these results. Okay? So just in graphs, this is before the policy happened in 1998. So this is the data that we have before the policy. If you see the left panel, it seems like nothing is happening at the cutoffs. They look similar. If I move to 2005, those on the left are now getting money. On the left side are getting the money, and you see a discontinuous jump. Employment in places that got the money increased, but that is coming from employment in micro enterprises. Okay? When you look at formal firms, nothing changes. So I'm just estimating these jumps. Basically, that's the idea. Okay? So I need to give a number to these jumps, and that's what I'm going to do here. I show a lot of numbers here. Forget about that. All I want to show you is that I do it across a number of functional forms, and I do it for a number of bandwidths. So this is of how close you are to the cutoff on the right and the left. That's what these numbers mean. So I want to say that total employment goes up by around 14% in these villages. Okay. Most of it is coming, so you can see a one-to-one map with employment in micro enterprises. Okay. With a 15%, 14 to 15% increase in employment in micro enterprises in these villages. If you see, nothing happens to formal employment. Okay. Again, one thing that should be kept in mind is that there are very, very few formal firms in these villages, and a lot of these formal firms already have electricity generators or don't really don't really rely on the government to provide these infrastructure services. Okay. So having seen that, I will now drill down into the firm. I will now look at firm level data. First, we found that at the village level, at sort of the aggregate level, it goes up. Do we find corresponding increases if I look at the firm level data? Okay. So this I will look at the NSS. Once again, this is an NSS round from before the policy. In 2001, you don't see this jump. When I look at the 2006 data, you see that there is this discontinuous jump for firms in districts that received this money. So again, I need to provide numbers on this jump, and that's what I do here. I find that employment in micro enterprises increases by between 9 and 12%, but the base was really small. The base was 2.5 workers. So you can think of it like that. These are different measures of employment, so employment seems to go up. No matter what sort of functional form I have on the running variable or what bandwidth I use. Okay. So again, just pushing this idea just to show you that I'm not doing anything hanky-panky. When I look at formal firm employment using the formal firm data, I find no results. Okay, so nothing seems to be changing for formal firms in these districts. That could be because there are very few formal firms, or because they already have these generators and do not depend on intense to the firm that already existed. Now we look at the extensive margin. Because of this policy, did firms come in? Were there more firms in these villages that got these grants? So did the number of firms increase in these villages, and was it or formal firms? Okay. So again, using both of these data sets. So what we find here is similar to what I showed you earlier. All of the left panel shows you what happens before the policy came in. You don't see any of these jumps. It seems like left and right are the same. Once you go after the policy, once the money is there, you find these jumps, especially for the at total number of firms in the villages, which is completely driven by micro enterprises. Again, nothing happens to formal firms. This should have been formal firms. Sorry. Okay, again, giving you numbers. There was a 13% increase in the total number of firms in the villages, in districts that got this money, and that is completely driven by more micro firms, more small firms in these areas. Okay. All right. So another cross check that we run here is that we have a question in the data set which asks the micro enterprise if they were established less than 3 years ago. Okay. So the question was asked in 2005. So less than 3 years ago would be 2002. One sort of in the last 3 years. So this is sort of an upper bound, but we still see that many of them are claiming that they were born in the last 3 years. It seems that these are young firms. Young firms are coming in the districts that, young micro enterprises are coming in districts that receive this money. Okay. I've spoken a lot about firms. What happens to individuals and households that live in those districts? So what we do is that we focus on wages, the number of days worked, and the household monthly consumption expenditure. And we're going to use the NSS household surveys for this analysis. What we find, again, a lot of numbers and no graphs, that wages go up by 12%. So wages were around 450 rupees, which is $8. Increases by 12%, so it's now $9, something like $9. Okay. The number of days worked in the last 7 days. So the question is, basically, they go and ask in the survey, in the last 7 days, how much did you work? Okay. And every day is divided into 2 halves. So in a day, you can work a total of 1. So it's divided into halves. You have to say, oh, did you work the first half of the day or the second half of the day? here we find a 3% increase in the number of days worked or number of hours worked, depending on how you want to put it, for people who live in the districts that receive the money. These households also spend more. Their monthly consumption expenditure goes up by around 8 to 12%. Yes.
So just clarify, those linear and quadratic, they represent respectively intent to trade and treatment of the people.
So everything that I'm showing you right now is intent to treat.
Okay.
Is that these are places where money should have gone. The linear and quadratic are on the running variable, the functional form of the running variable. Yeah. Okay, so 12%, between 8 and 12% increase in the monthly consumption expenditure, wages go up, and the amount of time you spend working also goes up. Okay, so these are the baseline results. Where are these results coming from? Now we look at some mechanisms. If this was indeed a scheme or a policy that brought in money for infrastructure, we should first see an improvement in the overall infrastructure at the district level. That's the first thing I should be able to show you. Unfortunately, we do not have very good infrastructure data at the district level. So what we do is that we use a proxy for infrastructure. We are going to use night lights as measured by NASA satellites at night to proxy for overall level of infrastructure. And I'm going to show you responses, self-reported responses of micro firms on questions related to infrastructure. Do you have a lower probability of experiencing a power cut? Did you have no access to raw materials? I'm going to say that raw materials is through the supply chain angle, which is through connectivity, and of course, power cut is electricity. And then I'm going to show you that whatever effects I find are even stronger if you look at industries that really depend on electricity. Okay? And they are even stronger in industries that depend on road infrastructure or transportation expenditure. Okay? And I will finally talk about what I mean with the last bullet point. Okay? So here, I am running these regression discontinuity regressions for each year between 98 and 2013. Okay, so each of these coefficients is measuring the discontinuity between the districts to the left and to the right. So each point here is that discontinuity. So what I'm showing you is that until 2003, 2004, there is no difference. Everything everything is at zero. Okay? The confidence intervals overlap with zero. So there was no difference in the night lights between places that received the money and did not receive the money before the policy came in. All of this time is before the policy. Then I look at each year after, and you see that there is an increase in the night lights. So there is an increase in the night lights in 2005, 6, 7, 8. Okay. And then what happens is that What happens is that in 2008-9, the government of India, the central government, expands this policy. They get this policy and introduce it to districts that had not received the money earlier. Okay. So once they do that, you see that the effects go down over time. There is no comparison group anymore. Okay. Everyone gets the money. So even those to the right of that cutoff now get the money. So now you see that these effects of night lights are dissipating over time. Okay. So this seems to suggest that at least in this interim period where this expansion of the policy had not happened, you see that there is a difference in the nightlight activity. Nightlight activity is what I showed you on the map earlier, between the districts that got the money and districts that did not, just around the cutoff. Okay. Is this clear? So it seems like activity is going up, infrastructure is going up, electrification is going up. Again, now coming back to the firm level questions, you see a negative sign, which means a decline on firms saying that they experienced a power cut. there has been a decline in the power cuts. Firm having no access to raw materials, there is a decline. There's a decline of 17% in firms saying that, oh, we cannot get these raw materials. So I'm claiming that this graph and this table shows that both the roads and electricity channel were working. The money came in, the district spent money on roads and electricity, and we show you some evidence on that. Okay? So if it was roads and electricity, these effects should be stronger in industries that use electricity intensively and in industries that use roads intensively. Okay? So what we do is we divide industries into tertiles into 3 groups. This is the highest tertile, use the most amount of electricity, middle amount of electricity, the lowest amount of electricity. You find that firms say that firms' experience with power cuts going down is the highest in the highest tertile. Those that are extremely electricity intensive, then it goes down as you go down in electricity intensity. Okay? It's the same for road intensity. And it's the same for employment. The employment is concentrated in micro enterprises in the highest tertile of electricity intensive industries. Okay? And then it goes down sort of monotonically. The results are weaker for road intensive industries, but it's also monotonically going down. Okay? You cannot statistically distinguish them, but sort of just this a bunch of these results together helps us come to this conclusion. Okay? This is, we think, an important result, and I think it helps us. Say why our results are also similar to the previous results that have not found effects of infrastructure. So let me go over this carefully. So what we are doing here is we are comparing village employment in micro enterprises and the number of micro enterprises at the village level. Those are the 2 outcomes we care about. We are going to look at villages in districts that receive the money and villages that do not receive the money. But now we are going to focus first on villages on both sides of the cutoff that had no roads or electricity at the baseline. So these are places that had nothing. They are across the cutoff, so some are places that get the money, some are places that do not. But before the money came in, both these places had no roads or electricity. And we find that if you compare 2 villages across the cutoff, if they did not have roads or electricity previously, you find no effects. Okay? So this is similar to a lot of these results where you provide roads to a really rural village and you find no effects, or you roll out electrification in places that had no electricity or roads and you find no effects. So we're claiming that these results are consistent with sort of Johannes's work or a lot of other work that people have done where they have actually found no effect. So I think our story is consistent with that. And we find that as soon as you look at villages that already had roads and electricity before the policy came in, that's where you find that employment is going up and the number of firms is going up. So our claim is that these results seem consistent. One reason why previous work may not have found effects of infrastructure is because you build a road in a really remote town, nothing is going to change. You give electricity to people who are really poor and don't have any appliances, they're going to have no need for it. It's not that they're going to suddenly have productive activities and they will create a firm. You only find that in places which already had something. There was already some activity going on. So this, I think, we believe that these results are consistent with some of the previous work which finds no effect. Okay. Okay. Finally, this is going to be my last sort of results slide, and then I'm going to conclude. So here we look at what happens to villages in places that got the money, and what happens to villages that were closer to the district headquarters. The district headquarters gets the money, and the district headquarters is deciding where to spend it, whether to spend it in villages that are close by or further away. Okay. So here we find that all these measures of employment and the number of micro enterprises is actually lower if you go further away from the district's headquarters. So it seems like the district headquarters is spending most of the money in villages that are nearby. Okay? Which is also consistent with this story because villages that are near the district headquarters are more likely to already have roads and electricity. Okay? So here it's saying the same thing, but in a slightly different way. It's saying that as the distance goes up, the probability that the employment in those villages goes down. The number of enterprises in those villages goes down. Okay? Sorry, number of enterprises goes down, employment goes down. So it seems to suggest that there is some political economy channel happening here. Of course, we are not completely able to shed light on that, but it seems like this has something to do with accountability where district headquarters, where districts spend money on, but we just want to hand wave. We don't want to give a concrete. We don't want to have a concrete take on this table, but it seems to suggest something that's consistent with some others have found, what some others have found also in the US, that the closer you are to the state's capital, the more likely you are to receive this state's funding. Okay, so just to say, these are boring slides. These results are robust. I do a bunch of things. First, you may be concerned that I'm picking my bandwidths, bandwidth around the cutoff. So I show you across a variety of bandwidths, going from 0. All the way to 0.3 in in additions of 0.01, and I show that all these results are the same. Again, the same. This is something that I showed you earlier in the graphs. If I just were to look at data from before the policy, I find no effects at the cutoff. Now, what I do here is that I change the cutoff. I say, what if I were some sort of a policymaker and I randomly change the cutoff to somewhere on the right? So you have this entire distribution. The cutoff was at 0. What if I drop all the treated districts, and now I change the cutoff? If I change the cutoff myself and not use the government's criteria, I find no effects. So it seems like this cutoff was real. This it's not that I find these effects no matter where I look for effects. Okay, so it seems like the results are robust across different cutoffs, across this hypothetical cutoff. And if I looked at before the policy, nothing seemed to be there in the data. I'm just going to conclude, and then we can talk for 2 minutes. We find direct impacts of an infrastructure improvement policy directed to the most backward districts, but most of these effects are coming from micro firms. We are able to provide some mechanism that it could be because both roads and electrification is improving, which is relaxing their production constraints. It's helping them with their supply chain. Electricity is important for their production, so it helps, and it sort of indicates that one very important place to look for when you're looking at the effects of infrastructure could be on these really small firms, because they unambiguously have a higher demand for electricity. They use the electricity, they have machines, than looking only at households. And this may be an important population that previous literature has missed when looking at the effects of infrastructure. Here. Thank you, Vince. So we can, yeah.
So first question, are the observations in your samples independent from each other? I mean, like, for example, like 2 villages or 2 districts that are close to each other, one gets the grants, one doesn't. You know, they build the electricity grid, but it's easy for them to secretly borrow some, right? It happens. A second question is, do you see there's any, how do you entangle the treatment effects between electricity infrastructure and roads, right? Like, other than connectivity and, percentage of power outage, how do you say that employment increasement is, what percentage due to road or what percentage due to the electricity?
So I have a good answer for the first, not so good for the second.
Okay.
The first question is the districts in the control group are not necessarily geographically close. So this thing that they can steal the electricity or get the same roads, they are only close in terms of that score. So that's the answer to the first question. The second question is a very important question. If I can disentangle how much of the effect is coming from roads versus electricity, with this data, it's actually very, very hard. Unless I have a structural model and I want to make some claims about, I need a theoretical model to drive these results. Then here it's very reduced form, so no, I cannot completely disentangle. I can just say that both are important. Which one is more important? I'm not taking a stand on that right now. Yeah. But that's a very important question. Yeah.
Okay, I don't have a few questions, but maybe just I'm not clear about that. The first one is there's an index showing like scoring which district should get the treatment.
Yeah.
I wonder, is that index from the government or your team constructed? And if you constructed, what's like the weights put on each score?
So there is a government index. It was done by putting equal weights on those three. We reconstruct and it's the same as the government index. So we don't only use the government index. We first check whether we are predicting it correctly. We are doing it. So we do this cross check where we reconstruct it and we check it against the government index. Yeah.
And the second question is like in the graph where there are 6 subgraphs. I saw on the left 3 there are like in each graph there are peaks in both before and after. I wonder if there's any explanation for that.
So on the left and the right, or only on the right?
On the left, I think.
So one is that as you move away from the cutoff, as the bandwidth increases, those districts are becoming very dissimilar to each other. It's like if as soon as you're moving to the right, they are becoming richer and richer and richer. The scores are saying, so you're going to see this humps. There could be some other kinds of things going on. That's why, the explanation in the RD is that you can only compare in a very narrow bandwidth. So I cannot claim anything. So all the results that I have, one thing that I didn't say, is a very local effect. I can only say that there was a 12% increase in this narrow bandwidth. If I extend it, you're right, they look very different. So I'm not making a general point about all districts. So you're right about that.
So after that graph, like all our other analysis are based on this
very close.
narrow.
Exactly.
So I was wondering how long the time space in which you actually did that, because from what I did observe from my personal observation, it seems to be tracking sort of value creation that's coupled through infrastructure coming to a particular place. So I was wondering about the time dependence on that.
That is a very fair question. I have two probably not very convincing answers. First is that if you see this policy it's working in places that already have some infrastructure. So it's not new infrastructure per se. It's more like, oh, there was already an electricity grid. You are just bringing in new transformer. So the path dependence in my claim is that the path dependence in places that already have this infrastructure is lower. You don't need to see these roads for a long time, and it doesn't take a long time for you to grow in these areas. The growth is coming in areas that already had, this baseline level of infrastructure. On top of that, I agree with you that there should be a time dependence, but here, because of data restrictions, we are only looking at between 2 and 3 years after this money came in. So maybe these effects look large to you. I don't know if that was the question.
Yeah.
My claim is these effects look large because they are happening in places that already had. It's like basically you're in size, you're building, not in size, that's a bad example, but there was already electricity and you sort of improve the grid line a little bit. It was broken or something. These are investments of that sort. They are not completely new investments, which take a longer time for the benefits to realize.
I have a long list of questions, but I'll just ask a few now.
Yeah.
The first one is, in your bandwidths, how many districts do you actually have in there, example?
It should be,
Let's say 0.02.
I want to say around 56 to 60.
Okay. And how do you estimate your standard errors?
It is clustered at the district level.
So have you considered doing randomization in defense?
I should. I haven't done it.
You're kind of borderline where clustering starts to break down. 50 is
Yeah.
absolute minimum. You can
Yeah.
The other question I wanted to ask was, do you know about other government schemes in these districts? Can you rule out the possibility of the same?
So that's a longer answer. So I'll talk to you after I've answered the other question. But I have an entire section trying to rule out the other things. Yeah.
Do you have a shorter version also?
The shorter version is that I've done my best to rule out other programs. So let me just give some examples. One is one of the biggest schemes that first used this the same criteria was the National Rural Employment Guarantee. That comes in 2007. So we restrict our data just before that. There is a road scheme and an electrification scheme also, which is provided based off of population cutoffs at the village. So there is this, Sam has this paper on, it's called the Prime Minister's Rural Road Scheme. And there is a similar scheme for electrification, which is given to villages based if they are smaller than, if they have less than 300 people. Okay. So what I show in this paper is that if I look at these population cutoffs, the number of districts are similar in both in the treated and controlled districts for me. So it's not that the government is differentially giving more money from these schemes for these other schemes to my treated districts as compared to my controlled districts. So, but I've done. I mean, there are other schemes as well, which I discuss in more detail. Yeah.
So, sort of building off of some of the other questions, the way that this policy was written, or maybe at least enforced, we had a policy in the United States for stimulus where they referred to things as being shovel-ready. So was there any project specification or sort of shovel-ready, or you said grants, but were they grants that were still project-based, or was it sort of just give it to the government and sort of no questions asked, apply generally, partial funding, full funding? I mean, were there criteria?
So the money was 150 million per year, right? Now the district officials, the head of the district would have to, he would have to discuss with all of these line ministries and roads department and different village heads. Then they would have to come up with a district perspective plan, sort of enlisting the projects on which they would want to spend the money. That would then go for approval. So I mean, the bureaucracy was still there.
And this is after the money has been granted.
That was my question.
It's sort of
timeliness.
So that pushes the timeline out even further.
Yeah, that's what we were wondering about, the timeline.
So basically, the announcement was made in 2003-4. Starting next year, this is going like 4, 5, 5, 6, 6, 7 is when the money is going to come in. So start making these plans, start making these, start identifying these gaps, and then send us these plans once they're approved. I mean, once they are approved, is not clear whether every plan was approved or not. I mean, there are some audit reports where some of the plans were rejected. Sure. But I mean, that was basically how it was done. But you're right. That's that was the procedure, official procedure.
And so I have a question for you. I feel like you did a good job of explaining why there was an increase in micro enterprises, but you didn't really address why there was no effect in formal enterprises. I feel like industrial manufacturers and certainly heavy industry have a different sort of electricity need or energy need than a lot of these micro enterprises. There's a certain level, a threshold, if you will, of electricity supply reliability that they need, and these small improvements to the grid wouldn't address that. And further, a lot of industrial producers that are in rural India come together and they form industrial parks. They provide their own energy through microgrids. They pave their own roads. They provide their own infrastructure because the Indian government, to this point, hasn't been able to do it. Is that the reason that you found, or do you have